Let's get right into electron dot structures. Why do we learn this? Because we don't really care about the core electrons. We want to show what is going on with those valence electrons, those electrons on the outer part of the atoms, because they're the ones that participate in chemical bonds. All right, up first, chlorine is a halogen. To get the number of dots, in other words, the number of valence electrons, just look at the last digit in that group number. Now this one coincidentally has the same atomic number, so don't look at that. Look at the group number. Group 17 elements have 7 valence electrons, so write the symbol and then put 7 dots around it. You put 2 on each side for now. So there's your dot structure for chlorine. Let's go on to sulfur. Sulfur is right below oxygen in group 16, so what do you think? Circle that. What do you think? 6 valence electrons, what we need for sulfur. 1, 2, 3, 4, 5, 6. There's your lowest dots for sulfur. Let's move on to aluminum. It's in group 13, so we need 3 dots around that one. 2, 3, and lithium. Let's see, let's go with this one. Just did this in our last problem. Lithium has 3 electrons, and it's in group 1, so it's only one of them is valence. And so we need 1 dot to show that. Again, just to emphasize all these elements which have their final electrons in the S and P blocks. All right. Based on which group it is, that's how many valence electrons. That's how many dots you're going to draw. Right, so for all of these elements, what I'm saying is all of these elements, they're going to have their valence electrons in the ns1, looking like 1. All right, the last s orbital is going to have 1. All of these alkaline earth metals, whatever is their last energy level, that's what N stands for, they're going to have 2 electrons in their s orbital. So there's going to be, that's why all of them have 2 valence electrons, your earth metals, and your alkaline metals are going to have 1. And if you go over here to group 13, all of them are going to have 2 electrons in their s orbitals, and they're all going to have 1 electron in their p orbital. So that's why we get 3 for all those group 13 elements, and so on. Right, and I'll just do the last one here. All right, the p block has 6 columns representing the 1, 2, 3, 4, 5, 6 electrons that can occupy that sublevel. So all your noble gases will have electron configurations of ns2. Right, they've passed the s block, and so that's full, and then np6. So all of them are going to have 8 valence electrons. In other words, they are the octets.